kind of see up there, we have our exit pipes for the whale up there. With those, like I say, with John's plan, we were able to figure out how many pipes we needed, how much water we've got to run. My name is Dave Maynard. I'm a project engineer with Turner Construction in Seattle, Washington. The project is the U240 Capitol Hill Station. It's a project for Sound Transit. It's extending the light rail system from the existing light rail system, and it's working north. It's a continuing process. They're working on more stations going north. There's stations at University of Washington, and the light rail actually goes all the way down to the airport in SeaTac. And this is one of the many stations in the system. My role out here is a project engineer for the concrete side of things, the structural work put in the concrete, and Turner's also the GCCM on the project as well. The items that we're using out here are the IntelliRock sensors. We're using maturity sensors out here that are logging both the temperature and the data of the concrete, maturity data of the concrete. In this case, we're using it to measure our mass concrete. This job has a lot of mass concrete in it, and so we need to measure our temperatures and, in this case, maturity. We're using maturity sensors and not just the temperature sensors. The maturity sensors are giving us that extra bit of data to confirm our strength. In this case, it's very important. We can't strip our forms until we get to 90%, so it's very important to us that we're up to strength, and it's very important to the owner as well. So it's good to be able to show multiple ways to confirm that we have the strength. If it's from cylinders or if it's from the maturity data in the sensor, we've been able to have those multiple points of data to prove that we're where we think we are. In this case, we have to stay under 145 degrees maximum temperature, and we have to make sure that our concrete also doesn't exceed a differential of 35 degrees Fahrenheit. And we're using these sensors to measure and record that data on an hourly basis over 28 days per our specifications. We're using it to make sure we meet the contract specifications and to make sure that we are following our thermal control plan appropriately. Make sure the concrete's doing exactly what we think it's going to do. We start by developing a plan to figure out where those sensors need to go, figure out which parts of the concrete we need to measure. After we have that plan, then we know where those sensors need to go. So we can go outside, we can tie these sensors up to the rebar cage or to wherever they need to be. In this case, we use the rebar to support our loggers. We install them in the wall and in the whale, tie them up to the rebar, run the wires for those sensors back up and out, exposed above the pour so that we can get back to them later. We'll place the concrete around the sensors. After the pour is done, then we'll go down and we'll check the sensors periodically to check the temperatures, the maturities. We'll take the readings, we'll bring them back upstairs, we can download them into the computer, and using the program we can look at and develop graphs on the maturity of the concrete, the temperature differential, all the important factors that we need to see with the concrete. At the end of the day, when everything's said and done, those loggers are still active for up to at least 2 years, we know for sure. We have loggers down there from a previous contractor that we can still connect to and read. The information never changes, it's always stored there, so at the very end we can go down, take that last reading, we can clip the wires short and we can pour them into the concrete. Nothing's exposed, nothing was ever there, but we've got all the information we need. Then with the IntelliCure box, we bring it up on the surface and we have it right next to our tester or our inspector. We'll keep it warmed up to about 73 degrees. We'll keep it plugged in and in the AutoCure cycle at 73. We'll make the cylinders and set them in that box. When the pour is all said and done, we'll get that box moved down to the pour where we can hook it up to one of the sensors that we want to mimic, and the box matches the concrete temperatures, and then we can go down and pull cylinders out of it periodically when we need to take a test break. And we're able to use that and get that better break as opposed to a field cure or under the blankets or anything like that. Well, this helps the project in that we've had a couple instances where we've been able to adjust our system, or our mass concrete system, to make sure we don't go over our specifications. We've had instances where our temperature is getting too hot, and we're able to know that when we go and check it, so we can crank up the water or we can put blankets in the appropriate place. It actually helped us avoid some non-conformance issues, because we were able to recognize problems ahead of time if it wasn't agreeing with what our plan was going to do, and we were able to see that that was happening. We were able to make a corrective action before we exceeded our specifications. So that was definitely a benefit. And on top of that, it's an easy system to use to report all of the data that we're supposed to report to our owner, including charts on the hourly basis, the mass concrete reports, the comparison between our max and differential temperatures. It includes very good tools for us to provide that information to the owner in an easy to read format without having to do a whole lot of extra work. The other item that we have out here is the IntelliRock MatchGear system. We're using that again to help prove our strengths. Field cures and test cylinders that are cast by our inspecting agency have a lot of variability in them, and we can't always ensure that we're going to have a good break. We could have variability as much as 2,000 psi in some cases on this job between cylinders, and that causes a lot of unease with our owner, especially in that, well, maybe we had one cylinder at 4,000 psi, but we had two at 6,000, and we're a little bit leery about that. The MatchGear box has been able to let us better determine what the strength of the concrete is in place. Mass concrete is brilliant in that it helps concrete mature faster, and the extra heat of that mass concrete does help us mature and get to strength faster than in a normal concrete placement. And with the MatchGear box, we're able to directly tie into one of those sensors, in this case the edge of the concrete. We can tie our box to that, we can match the temperature of that in-place concrete, and we can have cylinders that better represent the actual in-place strength condition as opposed to a cylinder that's sitting on top and maybe didn't get insulated quite correctly under the blanket or other problems. It gives us a much better and more reliable way really to confirm that our concrete is at strength and gain the benefit of mass concrete and show that we can get to strength sooner. And we have actually been able to reduce some of our form removal times. In this case, our job is related to both strength and days, not just strength, but we've been able to use that box to show our concrete gets up to strength sooner and help reduce those form times so that we can cycle faster than we might have otherwise been able to using field cures or anything else. It saves in all places. It saves on the material that we're renting, the form rentals. It saves on our labor in that we can cycle faster. We need less people with our systems that we have in place. It saves on our indirects. We don't have to keep our staff around as long. It saves our subcontractors, our mechanical, electrical, our coordination, because they can come in faster. The faster we get out of the way, the faster they can get in and do their work. And it reduces the overall time of the job. So, I mean, it helps in all facets of the job.